So what actually is symbiosis? Symbiosis is the interaction between two different organisms living in close physical contact. These relationships can be beneficial or harmful. There are three main types of symbiosis. Mutualism, where both organisms benefit. Commensalism, where one organism benefits while the other organism is not harmed. And parasitism, where one organism benefits and causes harm to the other organism. Here we have a leafcutter ant. A leafcutter ant has many different symbiotic relationships with many organisms in its environment. A leafcutter ant is also referred to as an Actinidae. Living on a localized region of the leafcutter ant is a black yeast called Phylophora. Looking at the individual relationship is one of commensalism. They both coexist, but they neither harm nor benefit off each other. Seems simple, right? We come across a question that ecologists get asked all the time. Are symbiotic relationships binary? What happens if we throw these two organisms into their natural environment where there's other organisms impacting their symbiotic relationship? We'll soon realize that it gets very confusing very fast. We'll first look at the most obvious symbiotic relationship that an Actinidae has. Its food source, Ascomyota, or a fungus. Leafcutter ants cultivate and protect Ascomyota, and in return, the fungus provides nutrients for the ants. This is an example of mutualism. Both organisms benefit. So far, everything is fine and dandy. Let's bring in our first villain, Escovophosis. This is strictly a parasitic fungi. This microfungi attacks the ant's food, the Ascomyota. It only harms the plant. This is a parasitic relationship. Through an evolutionary arms race between Escovophosis and another microorganism, the bacteria Pseudonocardia, leafcutter ants have become efficient at fending off this parasitic fungi, which brings in yet another symbiotic relationship, the relationship between the leafcutter ants and the Pseudonocardia. By themselves, leafcutter ants and Pseudonocardia have a commensalism relationship. Pseudonocardia have a place to live, but the leafcutter ants do not benefit. But when you put it into the context of their actual environment, it changes everything. It becomes a mutualistic relationship. The ants now benefit as the bacteria protects their food source and ultimately leads to their survival. Remember how I said it gets confusing really fast? We have yet another symbiotic relationship. In the beginning of the video, I described the individual relationship between the leafcutter ant and the Phylophora as commensalism. The yeast gets a place to live, but the ant doesn't benefit. But when we put their relationship in the context of the actual environment, things get shaken up a bit. The yeast now becomes a parasite to the ants. The Phylophora and the Pseudonocardia are phylogenetically related, as in both organisms have similar anatomical structure, hence why they both live in the cuticle of the leafcutter ants. The Phylophora acts as an antibiotic to the Pseudonocardia, suppressing its ability to fend off the parasitic fungi, Escovophosis. And once again, the ant's food source is now being eaten by the parasite. Here's a question. What is the impact of taking away an organism that seems to play a small role in the many symbiotic relationships in a leafcutter ant's environment? After all, the Phylophora is a parasite to the ants. Removing just one organism from an ecosystem could be catastrophic. Ecologists often refer to the rivet popping hypothesis. Removing one rivet from a plane wing might not do much, or even a second or a third, but there's a tipping point. At some point, popping out just one more rivet will cause all the rivets to pop and the wing to rip off the plane, sending it into a death spiral and ultimately ending in a fiery explosion. Unfortunately, we won't get to witness any explosions by removing Phylophora from leaf-cutting ants' ecosystem, but there are potential negative repercussions. Without Phylophora, ants would be able to eat at free will, with no real predators to stop them. This would lead to overpopulation. While this might be great for the ants, any overpopulation of a species negatively affects many other species in the environment. So what have we learned? Symbiosis is not binary. Ecosystems are very complex, and each organism has a specific job to keep the ecosystem in check. Removing even the smallest microorganism can throw off the whole system and can negatively impact not only organisms that it has symbiotic relationships with, but all the organisms in the entire ecosystem.